There are two main reasons why you would be using the factor theorem in algebraic division. One of them is that you want to factorise something like a cubic. Maybe you want to solve it, so you're going to factorise it, and then you can put each factor equal to 0, or a quartic, or anything basically higher than a quadratic. And the other reason, which you'll come to in the second year, is that you want to integrate a top-heavy fraction. So integration is part of calculus, where we're looking at rates of change, maybe areas under curves. If we want to integrate something that's got like a cubic or a quartic on the top, and then underneath something linear, then we break it up into these two separate bits, quotient and a remainder, and that helps us to integrate. So before we look at a particular question, let's look at the general situation that we are considering here. So I'm going to consider a quartic, but it could be a cubic, it could even be a quadratic, to be honest. It could be anything polynomial. And we're going to be dividing that by something linear, and I'm going to use x plus 1. Now, top tip, if this is confusing, which it often is, and even for me this is sometimes like, whoa, what's happening? To help understand, think about numbers, because they make sense. Well, they make a bit more sense. So I'm going to use 20 over 7 as an example. 20 divided by 7 is 2, remainder 6. And what that means is that as well as the 2, I still have 6/7. Now this mirrors this structure here. The 20 is the quartic, the 7 is the linear. And what we're going to be able to do is to pull out the quotient. I'm just going to use a Q for quotient. 2 is the quotient in my example, and also the remainder. So 6 is the remainder in my example with numbers, and we are going to pull out a remainder. And the remainder is still over that thing we were dividing by. So in my case, it's going to be over x plus 1. Now, there's another structure that we can generate by multiplying it through by 7 here, and it's going to be very important when we look at this algebraic form. So 20 over 7 times 7, 2 times 7, and 6/7 times 7. So you can still see that quotient there next to the thing we were dividing by, and then on the end very clearly is the remainder. Right, let's have a look what happens when we do the same thing here. So let's multiply both sides by x plus 1. We're going to get x to the 4 minus 3x cubed, add 4. We're just going to get the top, aren't we? The top is equal to the quotient, like the 2 here, multiplied by the x plus 1, and then the remainder, multiplying this by x plus 1 just gives the r, so there it is revealed nicely. Right, now this second line here is going to make something super duper clear, and it's going to hopefully make this factor theorem make sense. If you look at what we've got here, we have something times something, and this linear factor has come from the bottom. And what would happen if I chose an x to sub in that happened to make this 0? So if x plus 1 is 0, x is minus 1, obviously. If I sub in x is minus 1 to the the right hand side, then this is going to be 0. Anything multiplied by 0 is 0, so I'll just get r. Okay, so if I make that 0, sub it into the right hand side, obviously I get 0. But this is the same as this. So that means that if I sub minus 1 into this, I will get r. Sub it into the left hand side, get r. Okay. So this is a really, really simple way of finding the remainder. You just say, well, what would make this 0? That bottom bit, and you put it in the top. Okay, let's apply this same idea, but let's not look at it written in this form. Let's look at it written in this form. So when we first started, we were just looking at this quartic divided by the bottom. Then what we're saying here, because of the way it looks here, it's obvious. It's less obvious here, but what we're saying is, if you make the bottom equal to 0, so in our case that's x add 1 is 0, so x is minus 1, and then you sub that into the top, the quartic, which here was the left hand side but now is the top, then you get the remainder. Okay, so this is a really, really simple way of getting the remainder, and we can rephrase this slightly and have the factor theorem. So what the factor theorem says is that if you take the bottom and you make it 0 and you find out what the x is and you put it into the top, then if you get 0, now don't forget we know we're getting the remainder. When we make that bottom 0 and put it in the top, we're getting the remainder. But if you do division and there's no remainder, then you found one of the factors. So here, if I put the b over a into the top and I get 0, that means I've found one of the factors of f of x. Ax minus b is one of the factors. There is no r, there's only a quotient. Okay, so nice easy way to find the remainder. Now what do we need to do? We need to find the quotient. Now I'm going to show you a nice easy way. What you do is you write a L like there, like a grid, like an XY grid, and you write down the coefficients, that's the numbers in front of the top. So, but the thing to be careful of here, I'll put it as a tip, is to make sure all powers of x have a column when doing the division, when finding the q. So I'll show you what I mean. Here, how many x to the 4s? 1. How many x cubes? Minus 3. How many x squareds? 4. How many x's? None. That's what I mean. Make sure everything gets a column. And how many numbers? Minus 8. Okay, so let's make a note of what we've done here. These are the coefficients, that's the number in front of the top. That's what these are. Okay, now on the left-hand side, we're going to put the x, which makes the bottom 0. Right, now what you do is you there's one more thing we have to do straight away. Go down, this whatever's here, just start by just writing him there. That's the start. Okay, right, now you multiply diagonally downwards. So we're doing -1 times 1. Then you go up and you write the answer, diagonally up, write it here. So multiply and then write the answer here. So this is going to be -1. And then you add downwards. Now again, multiply. So that's going to be 4, write it here, add down. Multiply, write it here, add down. Multiply, write it here, add down. What comes out is the quotient. So this is the coefficients of the quotient, which is q, which is what we're after. And what pops out here is the remainder. In our case, we didn't have a remainder because I happened to be dividing by a factor, but if there was a remainder, it would pop out there. So, last top tip for this video is that you have to always finish these questions by writing what you found. Don't stop there. And don't just write the quotient. What have we actually found? We found out that x to the 4 minus 3x cubed add 4x squared minus 8 divided by x plus 1 is equal to this quotient. Now, these coefficients are the coefficients of numbers, x's, squareds and cubes. So this is going to be -8, 8x, minus 4x squared and x cubed, which I'll write in the other order because we tend to write them in decreasing order. So minus 4x squared plus 8x minus 8. Okay, so that's written it in this form, no remainder in this case. Multiply it all by x plus 1. There's the q, and there's the x plus 1. And you can see that what we've actually done here, this process, is we've factorised a quartic. Now, you may say, and this is a good point, where the hell did I get that from? So I magicked up x plus 1 out of nowhere. But the idea is that either you will be led towards finding out what this is, so they'll give you a hint or they'll tell you what this is to divide by, or it's going to be one that you could spot. So when you're finding Q and R, what you might need to do is you might need to find a factor by finding a root. So in this case, -1 is a root of the top. If I put -1 in here, I get 0. And then applying the factor theorem. How would I find a root? Just try, literally, if you try plus or minus 1, plus or minus 2, plus or minus 3, you're going to find something that works. They're not going to make it any harder than that. Right, last thing, how are we going to check our answer? Well, we've rearranged an expression. We had an expression here, not an equation, just some maths, and we've made it look different. We've made it look like this. So the way that we can check that is to sub an x into the before, which is this thing here, and the same x into the after, which is this thing here. So I'd get my calculator, type in 2.5 to the 4 minus 3 lots of 2.5 cubed, 2.5 squared, blah, blah, blah. Find out what it is. Then type this into the calculator with 2.5 as x, or any x. I just use 2.5, I don't know why. And they should come out the same. If they come out the same, we know they're the same, and we know we're right.